So now when we looked at this, we have seen that we're having a diffusion through the structure, even if it's 100% airtight. And that's the diffusion, that's the vapor transport through the material that was causing that. But when we compare that now with the air leakage, how much moisture is getting in our structure with this 1 millimeter gap, then we see already what's the difference. Yeah, if you're not controlling the air leakage, our vapor management has no chance, because how should that moisture getting out again if you're getting like 1,600 times more moisture in there? So how do we handle that? Again, thermal performance goes down, like a wet woolly jumper is not warm any longer. So we really need to keep that boon dry, really, really dry, so that it can perform to its best. Air transport is not vapor transport. There's a huge difference between it. Like air finds its way. If there is something, it finds the way. Moves through gaps and cracks, needs a physical hole, like a sponge that has physical holes, and then it can move through it. It depends on atmospheric pressure, wind speed, height different, the stack effect. Yeah, and this all has an impact on air tightness. So if you're building and designing high-rise buildings, because of the stack effect, you already need to build really, really airtight. So all this facade systems for high-rise buildings are already really, really airtight, and they normally work on that. And airtightness, really, you want to have a balanced heat recovery ventilation system. Vapor transport is random movement. It's just random movement, moves through material. Yeah, if the material is not vapor tight, then it moves through the material. It doesn't need a physical hole. It depends strongly on temperature difference, absolute humidity, and particle pressure. Yeah, so this is what that is the difference. So you see already, air just finds its hole. Vapor has random movements. So an overlap is okay for that, but not for that. Yeah, so from that point of view.